morning, everyone. Today we'll learn more about energies, and in the prior concepts we have learned about kinetic energy and potential energy, and today we'll learn with the new concept, new topic, that is law of conservation of energy. Let us start with our lecture number 5, law of conservation of energy. Thank you. Now there are many examples, lifetime examples that we can watch in our day-to-day life. For example, electrical energy is converting into light energy, wind energy is converting into light energy, electrical energy. And here also we are having some example. For example, electrical energy is converting into thermal energy. This oven is working because of the electricity, and car is moving, and as soon as we provide petrol in the car, which is a chemical energy, then only the car is able to move. Chemical energy, the sun energy, the solar energy is converting it into the chemical energy because of the radiance of the solar energy from the sun. Its radiations, the tree grows and it gets energy from the sun. Here a boy is moving just because of consuming a food, a chemical that is taken from the plant. Okay, so here by consuming anything we get energy, and the boy can ride a bicycle in its motion. Thank you. Now with some of the examples, we will take some one example by which we will prove the law of conservation of energy. Let us start. Now let us take an example of law of energy, that's the free fall example, and we need to consider a body of mass m freely falling under gravity of height h. From height h, that from the height h we are falling the body, and it is a free fall example. So what is there now in this concept? We need to take the body at the height h, and from the height h we need to fall it. So the concept starts from the free fall, that we need to fall the object. Suppose we are taking the ball over here, that we are falling the ball or any kind of object from the point A. Now what we need to know at position A, if this is the position A, obviously the body is stable over here, there is no motion, and the initial velocity will be 0. So what is this? Initial velocity of the body will be 0. That is, u will be equivalent to 0 over here. Obviously it is not in motion, and there will be 0 velocity at point A. Thus the kinetic energy, if initial velocity is 0, obviously kinetic energy will be equivalent to half m u square, and if u is 0, then obviously the kinetic energy will also be 0. Then K will also be equivalent to 0. Potential energy will be equivalent to, that is U, that is mgh. Obviously the body is at height, and also we know about the formula of the potential energy as we have derived in the previous sections, and that is mgh, and where is m is mass, g is acceleration due to gravity, and h is height of the object, where the object is taken. Obviously the U, that will be the potential energy, that will be mgh over here. And total energy is always equivalent to kinetic energy plus potential energy. So what it will be? Total energy, that will be equivalent to kinetic energy plus potential energy, and we are taking kinetic energy as K over here and potential energy as U over here. That will be K plus U, that will be equivalent to 0 plus mgh, and that will be equivalent to mgh over here. Thank you. And now we'll talk about the position B. Right? We are falling the body from point A, and it will reach at some point B, at before the earth, and in the center the point will be B over here. And let us consider the velocity at that point B, v1, and as we very well know, the starting velocity, the initial velocity was already 0. So we need to calculate about the potential energy and the kinetic energy at point B. So let us start, and also at the end we will calculate the value of total energy. So what it is, let V1 be the velocity acquired by the body after falling through the distance x. Obviously, when it will reach at the point B, it will cover distance x from the point A. And as we very well know, initial velocity is 0. The distance it has covered, that is x at point B, and acceleration will be acceleration due to gravity over here, as we are working under gravity. So by the Newton's third equation of motion, that was v square is equal to u square plus 2as. Fine. So v square we have considered here as v1 square at point B. Initial velocity we very well know, that was 0 plus 2, fine with it, and acceleration is acceleration due to gravity, and s is what, x over here, because it has covered the distance of x, and we will consider x over here. What we need to, now we need to calculate both kinetic energy also and the potential energy also at the position B. So let us start. Kinetic energy is what, half mv square, and we have taken velocity as v1 over here. So the kinetic energy at point B, what it will be, half mv1 square. v1 square. Fine. And now as we know that v1 square we have calculated here is equivalent to 2gx, and what it is, half m into 2gx into 2gx. Fine with it. Now 2 and 2 will be cancelled over here, and what value we will obtain of kinetic energy, that will be equivalent to mg. Now at point B, height of the body above the ground is, obviously it is h minus x over here, because the hole is h and the x distance is covered, the value will be h minus x over here. So the height here will be h minus x. And potential energy, obviously we know what is potential energy. Potential energy is equivalent to mgh, and obviously what we will take here, mg h minus x. Now we very well know about the potential energy, and also we know about the kinetic energy at point B. We need to calculate total energy now. What it will be? Total energy will be equivalent to kinetic energy plus potential energy. You can consider this as equivalent to U also, as it is mentioned over here. So what it will be? So that is mgx is kinetic energy plus potential energy is what? That is mg h minus x. Fine. And what will be the values now? That is equivalent to mgx plus mgh minus mgx. This is of minus and this is positive. These both will be. Now total energy, as we have calculated in the previous, that was kinetic energy plus potential energy. Kinetic energy, we very well know that we have calculated mgx, and potential energy, that is mg h minus x, and this will be equivalent to mgx plus mgh minus mgx, and these both will be cancelled out, and what value we will obtain? That is equivalent to mgh. So total energy we will get at point B will also be mgh, and the point A, the total energy was also mgh. So in both these cases the values is mgh. Now let us talk about point C. So at point C, what will be there? Here In these both cases, the value of total energy was mgh. Now let us talk about position C. That is position C. What will be the total energy? So, as you very well know, now the object has reached to the ground, or you can take ball has reached the ground, and consider the velocity v over here, simple v, small v, and as you very well know that initial velocity we have taken, that was u, and here it has covered the whole height. So simply the distance we will take it as total as h, and acceleration will be also acceleration due to gravity. Fine with it? Now what we need to calculate? We need to calculate about the total energy, and before that similarly we will take the Newton's third equation of motion, that is v square plus u square is equal to 2as. What will the value of v square? Simple v we will take. Initial velocity was 0 plus 2. Here acceleration due to gravity we will take. And s is what? S is the total height we will take over here, because it has covered the whole distance from A point by covering the B point, and then it has reached the C point. So we will take distance S as h over here. The value of v square will be equivalent to 2gh over here. Fine with it? Now what we need to calculate? We need to calculate kinetic energy, that is half mv square, and obviously we will take here as kinetic energy half mv square, and we very well know about the value of v square now, that is half into m into v. What is 2gh, and 2 and 2 will be cancelled out now, and we have considered as mgh as kinetic energy over here. Fine with it? The value of kinetic energy at point C we have obtained mgh. Now at point C, the height of the body. What will be the height of body? Obviously it has reached to the ground. The height will be 0 over here, because there is no height as it has reached to the ground. So the height of the body will be 0.